Hi, so I got a question about one of the questions. There was a question on the homework one, and it was, what do I mean by how using Euler's method to estimate the true solution to within 0.001 or something like that. So I'll sort of do an example here so you can see what I mean. So here is, oops, let me share the screen. There it is. So here is GeoGebra. And here's a slope field. And the slope field, you can see up here is minus 2y plus x squared. I would write this on the worksheet as something like minus 2y, dy dt equals minus 2y plus t squared, because GeoGebra doesn't like t's, it prefers x's. And there's the slope field. You can have GeoGebra to set it up. You can ask GeoGebra to solve ordinary differential equations, solve ODE. You put in your right-hand side of your ODE and an initial condition, which is 0, 1. That's this point A here. And it'll solve it. And it'll assign it as a function. So f of x is the solution to this. And you can ask it, what's f of 2? And I'll tell you, it's about 1.2637. So this point B down here, that's x equals 2, y equals about 2.1637. And that's all very nice. What we want to know is, if I want to approximate the point B on this curve, starting at the point A using Euler's method, and I want to get within 0.001 or 0001 of the true y value, 1.2637, how many steps should I take and how long should each of them be? So here, our f of 2 is 1.2637. If we want to estimate that within 0.001 accuracy, that means we want to use Euler's method and make the step size smaller and smaller and smaller until when we look at what we get when we get to 2, the output is somewhere between 1.263 and 1.264. Okay. Yes, that's what I want. So we will change the share to go to Euler's method on Microsoft Excel. And here it is. How does Euler's method work? You put in your initial condition, which is 0, 1, as old t and old y. Your change in t is whatever your step size is. I entered it as $J, $1. That means that whatever I put in this cell here gets copied into every cell in column C. So I can change the step size all at once. Slope, that's my minus 2y plus x squared. So minus 2 times the old y plus the old t squared. Delta y, your change in y is slope times delta t. That gives you delta y. And then your new t is your old t plus the change in t. Your new y is your old y plus the change in y. And then we take these two numbers and we put them back down here. So new t is now the old t for the next line, and the old y, the minus 1, becomes the old y. So if delta t is 1, if I make the step size equal to 1, what does Euler's method tell me that I get when t equals 2? Well, it tells me that I get 2. And that's not a good estimate because it should be about 1.2637. So let's make the step size smaller. Let's make this step size 0.1. And now when we get down to 2, we've got 1.233, which is much better, but not great. One thing you notice is that every time you decrease delta t by a factor of 10, you get about 1 digit more of accuracy. So we've got 1.233935. We're after 1.2637. So we've got the first digit right, 1.2, but we want 1.26, not 1.23. So let's make delta t smaller. 0.01. Oops. 0.01. Changes all my delta t's. And of course, now 2, t equals 2 is way down here somewhere. It's there. So 1.26073, that's the y value that we get for out of Euler's method when t equals 2 using a step size of 0.01, but we want 1.263, and we got 1.260. So we want one more digit. Let's make our step size 0.001. And now 2 it's about 2,000 steps, I think. Get to 2. We scroll way down to about here. So there's t equals 2, and Euler's method gives us 1.263,436, and that's within 0.001 of the actual value of 1.2637. Right, so there's the actual value that we computed using GeoGebra, and there's our estimate using Euler's method, and they're correct to within 3 digits. There we go. So the step size of 0.001 and 2,000 steps of Euler method has Euler's method approximating y of 2 to within 2 digits. Euler's method is not a particularly fast converging way of solving estimating differential equations, but it is a good for sort of basically understanding how some of these things work. So if you have other questions, email me and I'll try to make more short videos to explain stuff. So now I have to figure out how to stop recording. There it is.